hard and soft water. Hard water are those which does not form leather or difficult to form leather on reaction with soap. It does not form. But soft water can easily form leather on reaction with soap. Now, how it occurs? Supposed to be a soap, sodium stearate, C17H2N plus 1, that is 35 COO minus Na plus, on reaction with metal ion present as impurity will form precipitate of this and does not form soap. Precipitate and thus no leather. Okay. Now, hard water can be distinguished in two segments: temporary hardness and permanent hardness. Temporary hardness are mainly caused by the bicarbonate ions present in the aqueous medium. This will be salt of calcium and magnesium mainly. Whereas the permanent hardness are caused by the chloride and sulfate ions mainly of calcium and magnesium ions. Temporary hardness can be removed easily, but permanent hardness are somehow difficult to remove. The result will be soft water, which will be our desired. So increasing the softness. Okay. Now, temporary hardness can be easily removed by few processes. First of all, we will discuss by boiling. When we boil the metal bicarbonate of calcium and magnesium, it will simply be converted into metal carbonate and gets precipitated, and the residual CO2 will gets evolved from the solution, and the rest will be H2O. Next process will be the chemical process, where we will use Calgon, calcium gon. It is actually sodium polyphosphate complex salt. So we will first write here M2 plus, and M will be Ca or Mg. On reaction with Na2, Na4, PO3, that is the complex ion, we will add big hole 6. It will transfer into Na2M2PO3 whole 6 plus 2Na plus. This complex salt gets dissolved in aqueous medium. So it will reduce the hardness of water. Now, removal of permanent hardness. It can be done basically in two processes. First of all, we will discuss the inorganic ion exchange process. This is removal of temporary hardness. In the inorganic ion exchange process, we will add zeolite, whose commercial name is permutit, or artificially make zeolite. It is actually sodium aluminium silicate. Sodium aluminium OH H2O. In the suffix, here will be Al2SiOH. Now, how it reacts? In the general formula, we will write it Na2Z. When calcium chloride supposed to be present here, it reacts with Na2Z to form CaZ plus NaCl will form. NaCl is dissolved easily in the water and does not increase the hardness, and the calcium zeolite will get precipitated. How this can be recovered? Calcium zeolite on reaction with sodium chloride will regenerate this form CaCl2. That is regeneration. It can also be applicable for magnesium. Whereas the organic ion exchange process, we will use resin. The RH can be cation exchange resin and ROH can be anion exchange resin. The cation exchange resin on reaction with metal ion 2 plus will form R2M plus 2H plus, that is cation exchange. And in case of anion exchange, X minus, when X can be chloride, sulfate, etc., will form Rx plus OH minus. X can be Cl minus. If it will be sulfate, then we will balance the reaction accordingly. And here R can be, sorry, M can be Ca2 plus Mg2 plus, etc. After ion exchange, resin can be regenerated. The cation exchanger can be regenerated with application of acid, will form this and MCl2, whereas the anion exchanger resin on reaction with base will react like this way. So basically, by definition, resins are giant hydrocarbons having acidic part either or basic part like this NCB, NH2, OH, etc., and capable of exchanging ions. And lastly, I will discuss about hardness scale of water, which is expressed in ppm, that is parts per million, and defined as the parts by mass of calcium carbonate equivalent of calcium and magnesium salts present in 1 million. That will be actually 10 to the power 6 parts of water, parts by mass of water.